Alright guys, I'm gonna try and do this quickly, but I'll go through each section and kind of explain what I think you should know. So for 7.1, a lot of just 7.1 is just gonna have we're just gonna have questions that are reading the context and finding the equation that match. So like for this first one right here, it says P of t is the size of a population at time t. Which of the following differential equation describes linear growth in the size of the population? So basically it's saying that P has linear growth, meaning that its derivative should be constant. So that's going to be A. Other ones are going to just try and, like B is probably the one that's going to try and get you the most, or maybe even D. D will give you that's an exponential derivative, since it's proportional to itself. But so yeah, it's got to be A. For something like 2, yeah, you're just trying to match everything with the equation. So pay attention to like the rate of change of something with respect to something. So it says the rate of change of volume with respect to time. So that's going to exclude A and B since those aren't giving you derivatives. And then it says it's directly proportional to the square root of volume. So that'd be K times by the square root of V. It's not going to be B because that's not a derivative. But you can see for E, that's K times the square root of volume, which is directly proportional to the square root of volume. So I'm not really sure if the rest of these are really all too good. 3, I think, is a good one to look at. 4 and 5 are also good, but if it were me and you guys want a little bit more practice, maybe jump into 7.1 homework. And I think those were actually really good questions. Or 7.1 notes, if you go over the examples that we did in the notes, I think those are really good examples. So if you want to be sure that you know how to do these problems, there's my tip for you on that right there. For 7.2, this is verifying solutions to differential equations. So let's see what we have here. A lot of these are kind of tedious work, to be honest, which I know isn't really great, but it happens. So it might just come down to having to check a couple of times. So I think 1 would be a good one to study. Solve for K. So you'd have to plug in something for Y. You have to plug in something for Y double prime. A problem that students were having during the review today is that they're not remembering to distribute that negative. So you have Y minus Y double prime over 4. Whenever you plug in something for Y double prime, it requires 2 terms. And so that negative would have to distribute to both terms. So that's something that students are forgetting to do. So keep that in mind. However, there should be a pretty good explanation. Does this one give an explanation? I can't even remember if this one gives an explanation. Let me see. Yeah, there's an explanation there. Once you, not all of these have explanations, but some of them do. Let's see. 2 you can do. I don't think I'm going to do a question like 2 on the test. Let's see. 3 is very similar to 1. 4, I think 4 would be a good one to do. I think I can see myself putting one like this on the exam. So you'd have to find the derivative to plug in for dy dx. Don't forget that for C and D, you're going to have to use the product rule in order to take the derivative. And then you can plug in the y for 2y. I think 5 would be a good example to do. I think if you do 5, that would be a good one to practice for the test. I think that one's a great one for if you want to do 5. I think I would recommend doing 5. I think 6 would also be a good one to do. Yeah. All right, let's see. So 7.3. Oh, the slope fields. Yeah, you guys were having a hard time with the slope fields, which is understandable. They can be hard. So as far as pointers, what you can do for slope fields is pay attention to special values of 0. So whenever you see like at y equals 4, all the tangent lines are horizontal, which means that the slope is always going to be 0 at 4. However, that's not too helpful, because as you go down to the options, every one of these will be 0 when y is 4, since every numerator contains 4 minus y. So that's unfortunate, that's not too helpful. But y equals 0, that might be helpful. So again, at y equals 0, it looks like we have horizontal tangent there. So try and eliminate those. So like for A, if you plug in y equals 0, you'd get 4x over 4, which would be equal to x and not 0. So I don't think it's going to be A. If you plug in 4 for B, no, if you plug in 0 for y, if you plug in 0 for y on B, you'll get 0 times by 4, which is going to be 0. So it could be B. And then you'll get the same results for C if you plug in 0 for y, and you'll get the same results for D. Okay, so you have eliminated A. Now, I think it's also important to note that y values above 4 y values above 4 are always positive. Y values between 4 and 0, y values above 4 are always negative. The slopes are negative. Y values between 0 and 4, it looks like the values are positive, and the y values below 0, the slopes are always positive. So this makes me think that C is not going to be an answer, because if you look here, notice that for all the y values, so at y equals 2, y equals whatever 2.5, y equals 3, you can see that horizontally the tangent lines are always the same. So if the tangent lines are always the same horizontally, that means the derivative is always going to be defined in terms of y. So that would rule out C, because C also needs an x value in order to determine slope. So I don't think it's going to be C. I don't think it's going to be C. I don't think it's going to be A. It's going to be B or D. Now, a big difference between B and D is that D has y squared while B has y, which means that negative numbers are going to affect this. Because if you plug in a negative number for y squared, that's always positive. But if you plug in a negative number for y, that is going to be negative. And so let's try plugging in a negative number for y. So if I plug in any negative number, let's say I plug in -1. If I plug in -1, if I'm looking at B and I plug in -1 for y, I get -1 times by 4 minus, so that's going to be -1 times by +5, which gives me a negative slope value. But the slope should be positive for values that are below the x-axis. So it's not going to be D. Or sorry, not going to be B. It's going to have to be D. So, yeah. There you go. So looking at those type of clues. Something similar here. Think about those type of clues. So I think y equals 1 is a good number to check because it's always 0. I think x equals 0 is also a good number to check because that's also always 0. And then try and think of positive and negative slopes. Where is it always positive? Where is it always negative? So like in the bottom left quadrant, the slopes are all positive. In the bottom right quadrant, slopes are all negative. In the top left, above y equals 1, slopes are negative, and in the top right above y equals 1, they're all positive. So if you want to plug in a number like -3, -3, so somewhere in the bottom left quadrant, you can plug in those numbers and then make sure that you get a positive number. And if you get a negative slope, then you can start canceling out some options. And then you can kind of do the same in other corners of this right here. So you can do that. Again, just try and look for those clues. I know it can be pretty hard, but I think you guys can manage it, okay? if there are any specific ones, try and reach out to me beforehand, and I'll try and give an explanation. Just email me. Just say, hey, Unit 7.3 questions on question 6 or whatever. I don't understand why it's this, and I'll email you back with an explanation as soon as I can. But yeah, I know that can be hard, but I think you guys can do it. Okay, there's a lot of practice. That's the thing. I gave you guys a lot of practice ones here, so hopefully by practicing all these ones, it'll make the ones on the test a little bit easier. Okay. All right. So that'll be for 7.3. No 7.5 or 7.4. 7.5, this is exclusive to BC, so if you're on AB, if you're in the AB class, you don't need to do any of these ones. I honestly don't think 7.5 is going to be a problem for most because it's pretty procedural and you're just using a table. So if you can do if you can do 2 of these right here, you should have no problem doing the ones on the test. So if you want to try something that's kind of out of the ordinary, 3 looks like it's kind of different because you're using a table. Let's see if there anything else that kind of looks out of the ordinary. That one uses a table. Sometimes how y is defined might be different, but yeah. If you don't know how to do Euler's method, you can watch my homeworks, or you can watch the videos on the College Board for 7.5, but yeah, there's really nothing much to say. If you do have questions on Euler's method, just maybe YouTube it or come and see me before the test, and they're really easy. Shouldn't be a problem. For 7.6. So for 7.6, this is separation of variables, but not solving for the constant. What the JK, I guess this one you're going to solve for the constant, I guess. I didn't think that there was any. What's 7.7 then? I thought 7.7 was supposed to be. I have a feeling that 1, 2, and 3 were supposed to be in 7.7, but whatever. So 7.6, just so you know, are going to be questions where you're going to separate variables, but you're not going to solve for an initial condition, meaning that you should have a plus C in your answer. So these ones, like 9 and 10, should give you a full explanation. So if you want to, oh my gosh, so slow. What in the world? This isn't even on one of your guys' Chromebooks. All right. Yeah, it should give you an explanation for 9 and 10. 8 should also give you an explanation. Yep, it does. 7 should give you an explanation, although 7 is far too easy. 6 should give you an explanation. 5 should give you an explanation, except I think some of these were on your homework, but that's okay because they're still good to practice. 4 is one that would look like it would show up on a free response question. So if you wanted to do this one, or you can look at the free response questions. I don't think I'll use 4, but yeah, I'll try and keep it pretty simple. Now these ones look a lot more like 7.7 because you actually have an initial value. So let me try and jump into 7.7 questions. And let me try and do a couple of these ones since I know that there were some questions. So now the question 1, it's okay, but I don't think it's something that I would put. I'm not trying to use any. I'm not trying to layer questions from 7.1 by using U substitution, if that makes sense. So the questions that I'm going to put on the test, they're going to not use additional methods of integration like U sub or integration by parts. I'm trying to avoid doing that since I don't really want you guys to spend too much time on these problems, and those can often take time by using U sub, and so if that gives you guys any comfort, then cool. But I don't want you guys to use too much advanced techniques of integration. So for 1, you can try it. Does it give an explanation here? It does. So you have to use u substitution here. You can use u is equal to sine of x, and then yeah, just follow this process right here. You guys should be able to see this, I think, but yeah, you can use u sub. But I'll be honest, I'm probably not going to use a question like 1. I don't think I'm going to use a question like 2 either. That doesn't look like something I want on the test. I can see myself doing a question like 3. However, I don't think I would include the domain. I think I wouldn't include that as part of the question. I think I would just say find the solution. I'm trying to find one that would be one that I would like to use. I think 4 would be too easy. I don't think I'd use 4. I could use 5. I can see myself using 5, but not with the domain. Oh wait, that one doesn't use a domain. I can probably see myself 6, 7, 8, 9, 10. Second, I'm going to quickly go back and look at 7.6 questions. Those 3 from over here. Okay, I'll be honest. I think 3 from 7.6 is a question that I'm going to use on the test. I think I'm going to use something very similar to this. So I think question 3 is a good one. So let me go ahead and do that one. So dy dx is equal to 2xy. So dy dx is equal to 2xy. We have the initial condition of f of 0 is equal to 5. Excuse me. F of 0 is equal to 5. But it wants us to evaluate the function at 2. It wants us to find f of 2. So that's actually kind of like a second part. But I can see myself using something like this on the exam. So I'm going to separate the variables. So I'm going to divide by y. So I'll get 1 over y dy equal to 2x dx. And I'm going to anti-differentiate. And so that's going to be the natural log of y equal to x squared plus c. And then I'll plug in my initial point to solve for c. So I'll get the natural log of 5 is equal to c, since I'm plugging in 0 for x right there. So then I would have the natural log of y is equal to x squared plus the natural log of 5. And I'll use base e to anti-differentiate, or to, sorry, not anti-differentiate, but to solve for y. And y will be equal to e to the x squared times by 5, because of a rule that I keep stating. If you want to go look at the free response questions, I do that in just about every free response question. So y is equal to 5e to the x squared. The final step is to actually find f of 2. So f of 2 will be equal to 5e to the 4th. So 5e to the 4th, that will be d. There you go. Again, definitely recommend doing 3 as a question for 7.7. I think that would be a good one to do. Okay, now let me try and find another one from the actual list of questions. Sorry, I don't know why that's in 7.6. I guess I wasn't paying too much attention. Well, the thing is, I guess this one is kind of like that. So not only are you solving for an equation by using separable differential equations, but you're also plugging in a value after you do that. So this one might be a good one too. So you're not only going to solve for the equation of y, but afterwards you're going to plug in pi 6. So, okay. Let's see if there's another one. Let's do... Let's do this one right here. Well, I don't know. Yeah, let's do this one right here. dy dx is equal to x squared over y. So dy dx is equal to x squared over y. What's our initial condition? Our initial condition is y of 3 is equal to negative 2. Is that negative 2 or positive 2? Negative 2. Alright, so separate the variables. So I'm going to multiply by y and get y dy equal to x squared dx. I'm going to anti-differentiate like that, and I'll get 1/2 y squared equal to 1/3 x to the third plus c. I'll plug in my point, so I'll plug in 3 for x, I'll plug in negative 2 for y, so 1/2 negative 2 squared equal to 1 over 3 times by 3 to the third plus c. So that's going to be 1/2 times by 4 equal to 1/3 times by 27 plus c. That's going to be 2 is equal to 9 plus c. So c would be equal to negative 7. So I got 1/2 y squared is equal to 1/3 x to the third minus 7. I'll times by 2. So then I'll get 2/3 x to the third minus 14. Take the square root, so y will be equal to the square root of 2/3 x to the third minus 14. Oh, this is a good one. I'm glad I chose this one. Yeah, this is a good one. I'm glad I chose this one. I think this is a good one to study for the test. So, for example, we have the answer of positive right here. But remember that roots can be positive or negative. So keep in mind that our original equation, our original condition was that f of 3 would be equal to negative 2. But if you plug in 3 right here, you're going to get 27. You're going to get 27 here, divide by 3. That's going to be 9 times by 2 equals 18. 18 minus 14 would be 4. And I'll get the square root of 4, which is going to be equal to 2. But we want it equal to negative 2, which means we have to put a negative in front right here. So if you do that, that's why the answer has a negative in front of it, and that's why it's going to be E and not D. So that's a good one. If there are any other ones that you guys want me to do, just reach out to me in email, and I can do more of these, okay? But kind of running low on battery if you guys can't tell, so let me move on. So 7.8. So for 7.8, if dy dx is equal to 4y, and if y equals 4, what is 7.8? 7.8 is exponential modeling. And so understanding that for exponential equations, basically it's just pure algebra, what we're doing here. The only calculus that you need to know is that dy dt is going to be equal to k times by y. This is an example of an exponential model. This is its derivative. It means that the derivative, the rate of change, is proportional to itself. Okay, and if you do see that it's proportional to itself, or it specifies that it's proportional to itself, that means that the solution is y is equal to the initial amount times by e to the kt. This might also look like y is equal to p e to the rt, or a is equal to p e to the rt. You can say y is equal to y naught e to the rt. There's a lot of different ways you can write this same equation. I don't know why we've decided to choose like 500 different ways to write it, but it's all the same. So a lot of the times they like you to, from the information, can you pick out what the initial amount is? Can you decide what the actual amount is? And then K just refers to, that's a lot of the times K can be given to you and T will be given to you. Now there might be variations of this question. Let's see if I can find one. There might be variations of this question where you might have to solve for K. So what would be an example where you would have to solve for K? Well, if you're solving for K, you would have to know the rate of change and you'd have to know the amount at that time. So sometimes they might give you information that to piece this together, but you won't know K. And sometimes they can give you two equations, or sometimes they can give you enough information where they can give you a way to write two of these equations, solve for K in one, solve for T in the other. Or they might give you enough information where they actually give you the rate of change and the amount, and you can solve for K that way. You just have to divide this by the Y value. So there's that might happen. I don't know if I can pick one out here that would look like that. It doesn't look like it. Oh, 6 might be good. Yeah. Yeah, 6 would be one like that. But I honestly, no, yeah, 6 would be a good one. 6 would be good. So the weight of a population of yeast is given by a differential function y, where y of t is measured in grams and t is measured in days. The weight of yeast population increases according to the equation dy dt is equal to ky. Okay, so that's your hint that it's an exponential model, where k is constant. At t equals 0, the weight of the yeast population is 120 grams. So it gives you the population of yeast at t equals 0, and is increasing at a rate of 24 grams per day. So what that's saying, it's actually giving you the value of the derivative. So it's saying that 24 grams per day is equal to k times by, what was it, 120? So then k will be equal to 24 over 120. Now that will simplify, probably. I don't know what it simplifies to, but if I'm looking at these answers right here, so I think A, it would be a candidate for an answer because I can see that the initial amount is 120. I think B is also a candidate, and C and D are definitely not candidates. D is not because it's linear. C is not because it says plus 119, and that's not what you want. So I think it's got to be B or A, and I think it's got to be B. Yeah, so I'm assuming from that right there that this reduces to 1/5. And so that would make sense because that would make the constant 1/5, which is why the exponent is t divided by 5. So that's a good one. But I think they should be fairly easy. You're just going to use algebra. Let's see. I think this one would also be a good one. Any of these where you're actually going to have to solve for t, I think that would be a good one to study. Yeah. Solve for t or solve for, oh man, everything's dying right here. Yeah. Hopefully you don't have to do much work on 7.8 questions, honestly. And 7.9, this is again exclusive to BC, so AB, you don't need to worry about these problems, but I think these ones should also be pretty straightforward and pretty easy. So yeah, don't really know what else to really say about these ones. Just that I think they're going to be really easy. You just have to know how to read the question. So an important part about these logistic models is you have to know the formula. That's pretty much all it comes down to. So a lot of times they'll say dp dt, so the rate of change of the population with respect to t will be equal to k times by p, which looks exponential, but then they'll also have a part where they'll have m minus p, where m is the capacity, population capacity, so the population cap. And some things to note about the population cap, it occurs at the inflection point, or sorry, that's not what I meant to say. The population cap is here. The rate, so this will be its greatest when m is equal to half the population, when the population is equal to half of its capacity. That's what I meant to say, yeah. We'll just say when, greatest when m is over 2, when the population is at half of its capacity. That's a big part about these questions, so keep that in mind. I'm probably just going to ask questions based off of these numbers right here, if I'm being honest. I think that's all. So, and the equation itself. So, all right. If you have any more specific questions, just reach out to me. I can respond pretty quickly, and I can even just send a explanation in writing. I can just write it out in this on this page and send it to you. If you have time, anytime, like during lunch tomorrow, stop by my classroom. I'll have a little bit of time after school, but yeah. Good luck.